Welcome, everybody. This is Accelerating Platform Engineering with Pulumi. This is an AWS Immersion Day event, and my name is Josh. I am a solutions architect at Pulumi. With me is Torian Crane. Torian is a senior content engineer, and she will be helping out with chat and be giving a demo later about the new features for AWS CDK interop with Pulumi. Let's start with the Pulumi platform. Platform engineering, right? So what are we trying to do here? If you are familiar with some of the foundational materials of the sort of DevOps movement, platform engineering is really just one way of doing DevOps. I think it's kind of similar to the way that Scrum is one way of doing Agile, although I would not compare platform engineering to Scrum. I'm not a huge fan of Scrum personally. Or like Kanban or the other, or extreme programming even. Like there were these different methodologies of doing this thing called Agile. Platform engineering seems to have emerged as the sort of predominant implementation of the DevOps kind of theory. And the theory is that you want your operations team and your developments team and your security team all working in concert so they're not pulling against each other. And so, the way that this typically works out in platform engineering orgs is that you have an infrastructure team, and their job is to enable the development team and to have compliance with the security team. So the development team, they want to move fast. They want to get their code into production. They want to be able to operationalize it. It's also, you could also potentially, depending on where operations fits in your organization, you may have a separate SRE team, or the developers may run and operate the code that they produce. It seems like the latter is more of a trend in industry, based on my personal experience. And so, another part of what the infrastructure team is going to be helping the development team by providing some level of self-service in infrastructure, whether that's modules, whether that's a fully fledged integrated internal developer platform where all they have to do is do some sort of click and they don't have to touch code at all. There are different levels of self-service for different orgs. In my view, most of the time, some modules plus some templates is more than good enough for most orgs and most development teams to get moving a lot quicker than they would otherwise. So the infrastructure team's responsibility is to basically provide those guardrails to the development team and also to implement the policies that are authorized by the security team. The security team is typically going to be authoring the policies, not necessarily in code, but sort of stating what the policies are and then checking compliance. And so the infrastructure team in their interface to the security team needs to make sure that those needs are met as well. And if we are living the platform engineering dream, then we have a happy relationship between all three of these things. And the infrastructure team is kind of sitting in the middle of all this, enabling all of these different parties. And again, one thing we might be able to add to this slide is operations. So the part of the job of the infrastructure team or the platform team, whatever you call them, is to also provide those things in a platform that make day one and day two operations possible. That includes things like observability, on-call schedules, if you are provisioning those with infrastructure as code, which I would recommend that you do, things like that. So the infrastructure team also has to, in addition to making the infrastructure that an application needs to run, also has to have all the operational things in that platform eventually as well. Okay, so we have broken down this sort of learning path into three parts. We call them automate, secure, and then manage at scale. I would not take the arrows in this diagram too literally. This is a general flow for how you're probably going to be building platform engineering in most organizations. And also the order of these bubbles could potentially be reversed. And also it's not like, oh, well, you do everything in the automation category and then you start doing the first thing in the security category. There's typically going to be it's going to be like kind of a rolling target where you're maybe writing some IAC and then maybe you add a little bit of policy and then maybe you come back off and do drift detection and then maybe you finish the policy as well. But these are kind of generally the steps that you're going to see to implementing platform engineering in your org. All right. So, and again, if you have any questions on any of this, please hop on over to the Q&A tab. This is, again, downloadable. If you go to the handouts tab, you can pull down the PDF that contains this. You might find this material helpful at your org. And if you do, by the way, I would love to hear from you. My email address is just my first name at pulumi.com. So in order to enable this stuff, we have 3 products in the Pulumi platform. We have our infrastructure as code product, which is probably the thing that we are best known for. That's our flagship product. It's our oldest product. And our IAC product allows you to write infrastructure as code in general purpose languages for any cloud. And I'll get into some of the details of what it is that we support in the IAC product. Second, we have ESC, which is a security management tool. Essentially, the way ESC works is if you have secrets and configuration that are spread among many different places, maybe some stuff is in one AWS account in Secrets Manager, something else is in another AWS account in Parameter Store, something else is just raw configuration value that you have repeated on umpteen developer laptops. Well, the way ESC works is you can define that configuration or those secrets, whether they're dynamic or static, in one place. And then ESC will allow you to take that configuration and pass that off, either to a Pulumi infrastructure as code program or to any command line program. And then finally, our third product is Pulumi Insights. So Pulumi Insights will allow you to scan your cloud environment, take an inventory of your resources, and then do stuff with those resources. That could be visualization. Very soon, you'll be able to add policy to that as well. A lot of stuff. And then you can kind of, if you think about where that might be going, so Pulumi Insights is our newest product, and it is under active development. So there will be more to come soon. So diving a little bit deeper into the infrastructure as code product, when we say any language, the languages we support are Node, Python, .NET, Go, Java, and YAML. And then for things like Java, it's all the languages in the JVM. Likewise for .NET, we support all the .NET languages. And so why would you want to use general purpose languages? Well, there's a couple reasons. First, you're going to be able to be more expressive in your infrastructure as code by using just regular old syntax. So if you want to do a for loop, you can just write a regular old for loop in whatever language it is that you are comfortable with. Likewise, if you want to write if else, you just write an if else. You don't have to do weird ternary expressions that where you set a count equals a 0 based on some boolean. You just, if you want to create something conditionally, you create something conditionally. Second, you're going to be able to both consume and share Pulumi code using the packaging system of the language you're familiar with. So if you are a Python developer, you share code, it's just a PyPI package. If you want to consume a PyPI package, you can do that as well. And the third, your tooling is just going to work as expected. You're going to get autocomplete because Pulumi programs are just regular old fill in the blank here programs, Python programs or whatever. When we say any cloud, as you can see that with all of these logos in this lovely slide, we support all the major clouds, including, of course, AWS. We also have a Kubernetes provider that's very popular. We have support for Helm charts, and you can also use, we have a Docker provider that's very popular, and then we support a long list of smaller clouds and SaaS services, Datadog, New Relic, GitHub, GitLab, you name it, we probably support it. So that's the IAC product. Pulumi ESC, as I mentioned, the way it works is that you compose an environment. Environments are written in YAML. If you have secrets, they're all over the place. What happens is you authenticate against Pulumi Cloud, which is our SaaS product. And then ESC will grab the stuff on your behalf, give it back to you, and then you can pass that off to a Pulumi infrastructure as code program or any CLI program. One use case, for example, that it's really, really good at, you can grab a kube config, spit that out to a temporary file, and then run things like kubectl. It makes managing kubectl, it makes managing Kubernetes environments much, much easier. And there's like centralized RBAC built into Pulumi Cloud that allows, that says like what users can do what things. So that's Pulumi ESC. And then finally, Pulumi Insights. Again, this you can scan a cloud environment. We support all the major clouds, OCI as well, and Kubernetes. And we will probably be adding more things there as well. We will scan your account, take an inventory of all your cloud assets, and then you'll be able to do stuff with those assets, including visualization, and eventually you're going to be able to run policy against those resources, even if they're not managed by Pulumi IAC. Pulumi also has a policy as code tool called CrossGuard, which I will be demonstrating later today. Essentially, it will allow you to apply policies to your IAC. It works a lot similar to unit tests, but you can set the failure mode to be either a warning or an error. And you'll also be seeing today we have an infrastructure as code product, or excuse me, a CI/CD product built into Pulumi Cloud called Pulumi Deployments. It also has a lot of nice webhook features built in as well. So essentially, the reason you would want to use deployments is that it will streamline CI/CD, particularly when you are using kind of the full power of Pulumi Cloud, which I'm going to be demonstrating very shortly. Oh, yes. So we do have there was also folks are asking about the difference between Pulumi and Terraform. So let me just touch on that real quick. So going back to Pulumi IC. So the key difference to understand is that, like Terraform, Pulumi will allow you to manage resources in any cloud. So if you want to orchestrate dependencies between an EKS cluster and Kubernetes resources on that cluster, and then you want to update your DNS and Cloudflare, you can do that all in a single Pulumi program. So contrast that with like the CloudFormation or CDK, where you can only manage AWS resources. There is CloudFormation hooks as well, but for all intents and purposes, it's really designed to manage AWS resources. Whereas Pulumi and Terraform both allow you to manage resources in any cloud. However, unlike Terraform, Pulumi allows you to do this using general purpose languages, which at a certain scale are going to be significantly more productive than stuff like HCL or YAML. It's going to be much easier to write the stuff that you need to write when you are operating at scale. In addition to that, it's also important to understand that CDK has this transpilation step, and as the CDKTF, where we take your code, where they take your code and which is written in a general purpose language, and then that is transpiled to either HCL in the case of CDKTF or YAML in the case of CDK. And Pulumi does not have that. So when you are running a Pulumi program and you new up an AWS S3 bucket, as the program is running, that is immediately sent off to the Pulumi engine, and we start to try to figure out what work needs to be done to make your Pulumi program into its desired state. And it is, despite the fact that Pulumi does use imperative languages, it is still declarative in the sense of you only need to say what the desired end state is of your infrastructure, and Pulumi will figure out what needs to be created, updated, or deleted in order to get it to your desired state. So hopefully that clarifies things, folks. Okay. And then how about the integration points between Pulumi and AWS? Well, we have them throughout all three of our products. First, with Pulumi IAC, we have an AWS provider. We have a cloud control provider. We have the ability to use CDK constructs in a Pulumi program. And then we also have specialized packages that allow you to easily manage stuff like VPCs and EKS clusters. So that's the sort of IAC touch points with AWS. By the way, we also have policy packs that are specifically designed for AWS. Those are called compliance policies, and they are open source, and they will help you support common compliance frameworks like PCI DSS, ISO 27001, things like that. Second, with Pulumi ESC has integration with AWS in that it will allow you to grab values that are stored in either Secrets Manager or Parameter Store, and it will also allow you to grab temporary short-lived credentials from AWS via OIDC. So this is all really useful. You definitely want to be using OIDC short-lived credentials rather than access keys. It's much more secure. Finally, with Pulumi Insights, we have an integration with AWS in that we will be able to scan your AWS environment and then start managing those resources via the Insights UI. Okay, so it is now demo time. I'm going to shuffle a few windows here, so just stay with me. And I'm going to share my screen. Okay, so what you are looking at here is the new project window, new project wizard in Pulumi. Now, this is a demo environment, but essentially what each of these things are Pulumi infrastructure as code templates. So what I'm going to be able to do is, this is this sort of the sort of curated portal experience within Pulumi Cloud. So what I'm going to do is I'm going to go select one of these templates. This, for example, deploys an EC2 instance on a web server. And I'm going to click next. And I have to reauthorize in SAML. So I'm going to reload the page. And 1Password's going to do its thing. Okay, now I'm back in. Cool. Okay, so when I create a new project, it is going to give me a generated name of 3 random words. You can change that, of course. You can see here that so what's going to happen is Pulumi Cloud is going to create a new GitHub repo in my organization. And it's going to automatically start up. You can see here that I have deployments. It's going to automatically configure CI/CD for my Pulumi project. And within that pipeline, it's also going to run my automated policies. So you can see here, like, this is tying together a lot of different things on the platform engineering journey in a single place, which is exactly what you want to be doing. So I'm going to create this new project. I'm going to go create. It's going to be off and running. If you have questions, now is a great time to ask. So what's going to happen here? So this is Pulumi deployments. This is now starting a container. It's going to run a Pulumi up operation. So this, again, is going to take about 3 minutes. Again, if you have questions, now's a great time to ask. But I can show you what this looks like when it's complete. So this is, for example, what the I'll make this much larger. So this is the repo that was created. I actually ran this before with the same template, so the output's going to effectively be the same. I can hop on over to Visual Studio Code. I can show you what this looks like. So this is what it looks like to author a Pulumi program. This is in Python. There are different templates. I mean, again, Pulumi supports a bunch of different languages. Node, Python, Go, .NET, etc. We also have some questions I'm gonna answer real quick. So we have, can Pulumi be integrated with GitLab instead of GitHub? The answer is yes. The level of integration there is not quite to the same level of refinement. If you are a Pulumi customer or interested in becoming one, that's something that we could talk about, trying to improve that integration. But we do have a very good relationship with GitLab. They're excellent partners, and that's something that if there is sufficient demand for it, we would definitely do. The level of integration right now, so we do not have like the equivalent of a GitHub app in GitLab, but what we do have is we have the ability to integrate with GitLab's CI/CD product. And Torian, if you can search for my blog post with Pulumi and GitLab, it is on the GitLab blog. If you can post that in the reply, that blog post basically explains the entire extent of the things you can do between GitLab and Pulumi. And we also, I believe, have on our YouTube channel some materials on that as well. So I've done workshops similar to this where I am demonstrating similar things with GitLab. Okay, so back to the Pulumi authoring experience. So you can see here, this looks like regular Python code. That's because it is. You can see that I'm creating a security group here. If I wanted to add an additional ingress rule, I get autocomplete just the way I would expect. And so all this stuff is strongly typed. I'm getting all the help I expect from my IDE. And that's one of the benefits of using general purpose languages. I don't think doesn't look like we are using a ton of language specific. Yes. So here you can see we have a for loop, right? So again, authoring infrastructure as code in general purpose languages, just a regular old for loop. It's a really, really nice experience. Much, much nicer than the alternatives. You can also do things like create components as well. So this code base has somewhere it has might be defined in this file, but you can bring in local components. There it is. So you can create your own components. They are just classes typically in your language. There's a little bit of boilerplate you put around them, but if you want to make reusable constructs that are analogous to like Terraform modules, this is how you do it. You make component resources. You can also, by the way, because Pulumi is just regular old Python code, you could do this just as well using a static function if you wanted to. Okay, so back to Pulumi Cloud. So that's a little bit about the authoring experience. If there's anything else you want to see here, please let me know. We do have a question from Dimitri. Is there a published action for GitHub Actions? Yes, there is. Torian, if you can find the URL for that. But we do have a published, very, very well supported GitHub action. We dog food it internally all the time. So it is very well maintained. Okay, so that covers a little bit of the authoring experience. But if we go back to our project, so you can see here that this has now, I think, finished. Let's take a look. So the CI/CD is doing its thing. I think it might not have finished quite yet. No, it's not quite yet finished, but it is in the process of it. So I can show you what this looks like for a completed workflow. So I go into my stacks. I can sort them by last update. And here's the first time I ran this. So when all said and done, again, this is the Pulumi Cloud experience. By the way, Pulumi Cloud is also, in addition to doing all this fancy CI/CD stuff, at a very basic level, it is handling your state file and the permissions to it. So that's managed by Pulumi Cloud RBAC instead of having to manage all this stuff via like IAM permissions or whatever if you were using S3 as your backend. We are also managing your secrets for you, by the way. So Pulumi IAC will never store a secret value in plain text. So, for example, if you spin up an RDS cluster, and that we know that master password is a secret, and we will only store the ciphertext in your state file. So that's important to know for security reasons. You can also store additional. You can also store configuration values in your stack configuration file and mark those as secrets as well. Your stack config, and then you can commit your stack configuration to Git very safely, which is also more difficult in other IAC tools. So let's look at the output here. Let's go through. Let's see, updates. Yeah, let's look at the details here. Okay, so in Pulumi Cloud, we will automatically capture all of the CLI output. So anything that happens in the CLI, regardless of where you're running it, whether it's in a pipeline, in Pulumi deployments, or on your developer machine, we will capture that output. So that's really, really helpful to know who did what, where, and why. Now you can see here that we actually also ran our policies against this stack. The reason that these policies ran against this brand new created stack is that in Pulumi Cloud, you have the ability to centrally manage policy groups. And so you can take a policy pack. You can either take one of the ones that we have authored for you, or you can create your own. You can publish those to Pulumi Cloud and then say, for example, that these policies automatically apply to all stacks that we have in Pulumi Cloud. You can also manually manage those stacks as well. So what you can do is you can say, for example, we want every stack everywhere to run the CIS guidelines as advisory. But in certain production environments, we want to run the PCI DSS policy as mandatory, right? So this is really powerful stuff. So your security team potentially could be the ones to directly administer which policies apply to which workloads centrally in one tool. And that's next level platform engineering. If your org is doing that sort of thing, then you're doing platform engineering at a really high level. I do see a question in the chat that says, does each instance of the project deployment create a new repo? So by default, yes. However, if you want to keep a mono repo program, or you want to keep multiple Pulumi programs in the same repository, you can also do that. It's configurable within the new project wizard. In fact, I can show you that real quick. So if you go new project, And I select this template again. Under the repository, you can either say repository name and you can optionally specify a subdirectory. So I believe that will allow you to create a project in a subdirectory of an existing repo. So that answers that question. Let's see. So what else could I show you? Hop in the chat, hop in the Q&A. Let me know if there's something else to let me ask if there's any extra questions. So let's see. So we have someone asking, is there an equivalent of a Terraform state file in Pulumi? And if so, does it get created at the time of project creation? That's a great question. So the answer is yes. So the way that Pulumi works internally is you're running your program. Your program is going to say, I want an S3 bucket with this particular configuration. What Pulumi is going to do is it's going to take what you said you wanted and diff that against your state file, which is what our record of what has been done. We will diff those things, and then we will do whatever work needs to be done if there are changes to be done. So the answer is yes, there is a state file. Each Pulumi program, right, which is like a set of code, a set of infrastructure resources. Each Pulumi program has one too many stacks. The default stack name is dev, but in a production scenario, you would probably have dev, QA, and prod. Each stack in a Pulumi program gets its own state file. So the state files are per stack. And yes, it gets created not at the time necessarily of, so when you create a project, you are typically creating a state file for the dev stack because you are creating a stack. But to be precise, a state file is created at the time that a stack is created. And a stack, again, is just an instance of a program with its own config. So I know it was a little bit wordy, but hopefully that completely explains the answer to your question. Okay, so moving on. So we have shown the authoring experience. We've shown policy as code, a little bit about deployments. So you can go into my Pulumi program. Oh, and I need to take that question down if I haven't yet done so. Sorry about that. I literally always forget to do that every time I maximize a question. I always forget to take it down, and I'm very proud of myself. I'm very proud of myself for remembering to do it this quickly before I went on for another 2 minutes with that question up. So please send me some applause in the chat for being such a thoughtful presenter. Okay. So also, by the way, within your stack, you can view all your resources. For some resources, you can just jump directly to view them in the AWS console. That's pretty useful. If we go to this deployments tab, so this is our record of our CI/CD. We can also trigger different operations for Pulumi directly from the UI. So if we want to run a preview, say, hey, what's changed? We can do that. We can also run drift detection. So one of the ways that this particular demo environment is set up for is that you can do some really, really cool things with deployments. By default, this demo environment sets up two things. One, it sets up a TTL so that we, as people who are demonstrating the Pulumi platform, this will automatically take down our stack after a certain time has passed, and that prevents us from accidentally running up a potentially significant AWS bill. So you can create these things, schedule. You can add scheduled tasks to Pulumi deployments in a really convenient way. Second, we have this drift detection, and this drift detection will both detect drift and automatically remediate it. There's a couple of different ways you can slice these settings. So with drift detection, by the way, you can add a notification. So you can add a notification, for example, to send a message to Slack, or you can automatically remediate it. Now, coming back to a little bit of platform engineering theory or opinion or best practices, depending on how much of an expert you think I am, some things in infrastructure as code should be automatically remediated. Probably things in applications are generally things you want to be automatically remediated, like your actual workload. If that configuration is drifting, that's probably a mistake. However, there are some things where you should probably be sending a notification and then having a discussion with whoever it was that ended up changing the deployment or the infrastructure resources. The latter, where it's a discussion, networking. In my experience, very often things will go wrong with networks, and you do not have the time to wait to go through an infrastructure as code pipeline because the whole application is down or the whole organization is unable to access the internet. And you need to go into the console and change things. So, when it comes to drift detection is always good in my view. Always, 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 always. Drift remediation, that kind of depends. So hopefully that advice is helpful for your org. Again, networking, foundational infrastructure, I would not recommend automatically remediating it. Instead, I would probably have a discussion, but you always want that alert. You always want to know that your infrastructure has drifted from your desired state. So let's go back to these settings. So again, with these scheduled tasks, you can set them on schedule. You can auto remediate optionally if you want. And then you can also schedule any Pulumi operation. By the way, the typical operations are listed here. Update is to actually make the infrastructure the way I asked you to. Preview is show me what you would do. Update, by the way, always includes a preview. Like we will tell you what we intend to do before we do it. Refresh will refresh your state file. So this one's a little bit different than Terraform. In Pulumi, refresh does not happen automatically. It's a separate operation, and that is by design. And the reason we do that is for performance reasons. You can destroy everything in the stack. So that's what this first line is here, this TTL. So this will automatically tear down the stack. That's useful for things that you don't necessarily want to be up for too long. And then you can detect drift, or you can remediate drift. So remediate detecting drift basically runs a refresh, and it says, hey, there shouldn't be any changes detected. If there are changes detected, it will fail. And then remediate would be, I want to run this refresh. I don't care whether there are changes or not, but I'm going to run an update immediately afterwards to just make sure that whatever it is in the cloud is exactly matches my infrastructure as code. And again, there are different use cases for each of these. Okay, so that covers the deployments and drift detection experience. Again, if there's anything else you would like to see, please just let me know. But we're going to move on to Pulumi ESC. So check this out. So if we go here and we look at our plumi.dev.yaml, we can see that we have these this environment block right here. And so what this is this will automatically pull in these two Pulumi ESC environments whenever we run any operation on the stack. It doesn't matter whether we're running it in deployments or running it on my laptop. So what are in these environments? Let's take a look. So the first thing we're going to do is we're going to look at this cloud access AWS access environment. By the way, the slash is just like a folder path. Nowadays, most Pulumi ESC environments do have a folder path, but there is this concept of a default project. It's a little bit of a legacy thing. But for all intents and purposes, you're going to want to put stuff in projects. Okay, so this is a very, very small. What I'm going to do is I'm going to copy this, and I'll just paste it into Visual Studio so it's easier to read. Oops. All right, cool. So it knows it's YAML. Okay, so hopefully this is a little bit easier to read. By the way, when you're composing an environment in Pulumi Cloud, you can do it raw in an editor in the UI. There's also this table view. So if you want a little bit more of a formatted thing, you can do that. You can also do all this stuff from the command line as well. So there's a command line interface to ESC. But coming back to our environment, okay, so what do we have here? Okay, so the first thing is we have this AWS block. Okay, and then what this is going to do is this is going to grab temporary credentials for this role and for this session and for this duration. So when I run this environment, when I open this environment in ESC parlance, Pulumi ESC is going to hit the AWS API on my behalf, get me temporary credentials, and give that back to me to do whatever I want to. And when we say whatever I want to, what it's going to do is it's actually going to spit out environment variables that are temporary. And it's also going to pass through Pulumi configuration as well. So it's going to grab a region. Hopefully this is all making sense. Let me know in the chat if there's anything I need to do to explain this further. But hopefully this is all clear. Let me go check the Q&A tab real quick. So we do have a question from Dimitri that says, "Can I ignore drift for some attributes if I want to manage that part of a resource manually?" Yes, the answer is yes. So Pulumi has a whole list of options, by the way. So sorry, this is jumping back to infrastructure as code a little bit. There are a whole list of of options. Let me see if I can show you that. There's a whole list of options here that you can do in any Pulumi resource. That these are fairly intuitive, but it's worth noting. And these are all extensively documented. So, back to ESC. Sorry for the jumping around. Oh yes, we were looking at our environment here. Okay, so back to our environment, right? So the way an ESC environment works is this is an arbitrary key, by the way. You could call this my AWS, call it whatever you want it. This is how you grab dynamic secrets. They are functions in YAML, and each one of these has its own signature. So you would use a similar type of function if you wanted to grab a value from Secrets Manager or from Parameter Store. And then later on in your environment, you're going to say, okay, I want to output this path. So it's, for example, here AWS.creds. So that's your OIDC credentials. And then this here comes from the documentation. So, and we show you a complete example in the documentation in most places of how to use these dynamic credentials. So it's going to spit this environment variable out as an access key ID. And then you can also pipe certain things to Pulumi config. So this will set the default AWS region to the region that we have configured. All right. So that is this. And now, so one of the cool things, by the way, is that if we go back to our code, you can combine multiple environments so that you can get all of the credentials or secrets or configuration that you need in one place. In addition to being able to bring in multiple environments, for example, in a Pulumi program, in an environment itself, you can also do imports. So one common scenario is that you might have one ESC environment that has OIDC configuration. So that'll be like some role probably with full administration value, which is usually what you need when you're doing infrastructure as code. So you only have to define that once, and then you can import that into an additional environment that will pull in some secrets that you might need to run your Pulumi infrastructure as code program or whatever it is that you're piping. Another common scenario is that you might have one environment that has OIDC credentials for AWS, and the next might have your kube config for an EKS cluster, because typically in order to authenticate against an EKS cluster, you need IAM credentials plus a kube config. And so Pulumi ESC is designed to make those workflows really easy. Okay, so back to, let's see. So we have, and the other one is stack management. Let's take a look at what that environment looks like. So I'm going to hop over to the second environment, stack management. And so this one doesn't actually have much in it. It is importing a different environment, but this is what the imports syntax looks like. So you can combine, I know it's really tiny. Sorry, folks. Let me make it way larger. So as you can see here, it's just imports, and you can list the list of environments that you want to import. Okay, so if there's anything else I can show you, please let me know. But I think those are all of the things. So to summarize, Pulumi Cloud is going to make it very, very possible. Where did that go? Pulumi Cloud is going to make it really possible to automate this workflow, right? Where you are starting with, you're starting with a set of templates. Your application team, those templates are going to define common infrastructure patterns. Typically, they're going to be oriented around things like either like Kubernetes clusters or other sort of platform type things, RDS clusters, and then workloads that are going to run on top of some compute platform. You might, for example, in your organization have a template for an EC2 based workload, another one for a Kubernetes based workload, another one for maybe ECS, and then maybe another one for serverless. That's like a common way that you would break these things down. And so you, as part of the platform team, are going to be able to make these templates that serve the needs of your application developers. And you can also bake into these templates all the things that they need to operate these things. So whether, if you are using Datadog or New Relic or something for observability, you'll be able to bake those things in there. In addition, your security team is also going to be able to bake in your your policies and make sure that they automatically execute. And so you kind of are baking in both operations and security so that your dev teams don't have to worry about managing these things themselves. Okay, so back to the slides. Right now, I am going to hand off to my colleague Torian. Again, if there's anything else that you would like me to show in the Pulumi Cloud platform, any questions about platform engineering as a practice and how you can adopt it successfully, ask away, because I will be returning in just a little bit after Torian is finished. But Torian, I will now hand it off to you.
Thanks, Josh. Hey everyone, my name is Torian Crane, and I'm a senior technical content engineer at Pulumi. As Josh mentioned earlier, I'll be talking about and demoing the release of the 1.0 version of the AWS CDK adapter on Pulumi. With this release, we have greatly expanded compatibility with all CDK features, as he mentioned earlier. This includes assets, custom resources, aspects, and much more. As we go through this, again, remember, if you have any questions at any time, please feel free to drop them in the Q&A tab, and Josh will answer them, and I will answer them as we can. So let me just share my screen. Oh, I gotta take it over. Sorry, one second. Okay, so next slide. All right, so if you're not already familiar with the AWS CDK, it's very similar to Pulumi in that it is AWS's infrastructure as code framework that lets developers define cloud resources using familiar programming languages like TypeScript, Python, and Java. And then that is then synthesized into CloudFormation templates before being deployed to AWS. And so when it comes to using the AWS CDK with Pulumi, it actually means that you get the best of both worlds. So for example, with the CDK, there are some higher level constructs that abstract common patterns and sophisticated logic that may not yet be available in pure Pulumi. This means that you get access to things like AWS's L3 constructs that encapsulate best practices and complex architectures as defined by AWS. As mentioned before, using the AWS CDK natively means that it ultimately synthesizes down into CloudFormation templates, which are then executed by AWS. So by using it with Pulumi instead, your CDK constructs are translated into Pulumi resources, which are then directly provisioned via AWS APIs. And the main benefits of this is that you get much faster deployments since you avoid CloudFormation's template processing workflow. You also get more granular control over the resource creation order. As far as the third point goes, you have the ability to reuse code through object-oriented programming concepts. So that means using both together means that teams can reuse existing CDK constructs that they have already battle tested in their production environments, while also being able to build new infrastructure with Pulumi's native resources. Also, you just in general get access to other great aspects of Pulumi's ecosystem, such as policy packs, which will help strengthen your compliance posture. You get a more robust and granular state management system, and Pulumi deployments, Pulumi Insights, Pulumi ESC, all of the other services that Josh mentioned earlier. So like if you are in a situation where you're migrating from CDK to Pulumi, then the CDK adapter actually makes it much easier because it allows for a phased transition process, which still lets you have operational stability without having to rewrite everything all at once. And so now I'm going to switch over to my screen share. So I can actually demo to you what the resource creation looks like using the CDK adapter in Pulumi. Here I have basically the README that's found also in the GitHub repo where this example code can be found. You can also see that code in the GitHub repo in the Handouts tab. And this is just kind of walking through the prerequisites that you need to take, as well as the deployment steps that you need to take to deploy the code successfully. I'm actually going to go ahead and start the deployment of the program code just to get it started, because it does take a little bit of time for everything to deploy. At this moment, I already have this step completed. I have this cloned to my local environment, and I'm also in this particular folder. So the next thing I'm going to do is create a new stack. And then as part of your Pulumi configuration, especially when it comes to creating AWS resources, you need to set your AWS regions. And we need to do this both for the AWS and the AWS native packages, since both of those will be used in this example. And then the next thing you'll do is run the npm install command, which will install all of the necessary packages for this program to work. And now that that has finished installing, we'll go ahead and run Pulumi up. And as you can see, the process of creating the resources has started. So I'm going to go ahead and switch over to the actual code itself so we can dive into what the code is doing. Starting with the imports, of course, we have imported our Pulumi and Pulumi AWS packages. In addition to that, we've also imported Pulumi CDK, as well as our, let's say, CDK-specific import for EC2 instance creation or EC2 resources creation from CDK. As far as the definition of resources go, you define your CDK resources by creating this Pulumi CDK.app sort of function. And within this function, it will construct an instance of your stack, which you define here. And then underneath that, you basically just write your resources as CDK constructs. So here you see 2 resources we have created using the CDK constructs. And you have to make sure that you associate it with your stack as shown here. Overall, the structure of this particular example program code may look a bit different than what you might normally see in a native CDK project. This is just a more streamlined and more concise version of the same thing. I put together a simple example here to demonstrate that you can also follow this structure if you're more familiar with AWS CDK. It might resonate with you more by creating, a class that extends Pulumi CDK stack, and then you create your app resource and instantiate your stack here, and also handle your outputs as well. So the first set of AWS resources in the demo code is a VPC, a security group, and a security group ingress rule. And this structure here is very CDK-centric way to define the ingress rule. And so these are the ones that have been created with the CDK adapter. Beneath that, we have some additional resources. We have basically a get AMI kind of function. And we also have the EC2 instance definition. And one thing in particular that I want to point out is that you can, even though this is technically a Pulumi AWS resource, you can still reference properties from the CDK resources that you've created by using this stack output function here. So in this case, we've retrieved the subnet ID, the public subnet ID from the VPC. We've also retrieved the security group ID from the security group that we made above as well. And this is mainly to demonstrate that you can have both CDK constructs and Pulumi package resources in the same program code. At the bottom here, we have a demonstration of how exports work when you're using the CDK adapter. So you first have to kind of use this format to return it. And then you can export it as a stack output. And so using TypeScript's Pulumi TypeScript's format of exporting the output. This way that you can still actually reference any needed outputs that you need across stacks, or externally if you're having other programs that you're running that rely on values from your project. Okay, so now we're going to go back and check in on our deployment. We're going to go now navigate to the stack. And if you navigate to the resources tab, you can actually see all of the resources that were created with this project. One thing in particular I wanted to point out is that you can see that these are the ones specifically made using the CDK adapter because it's prefaced with CDK construct, and these are the ones that were created using the AWS Pulumi AWS package. So you're able to see all of this information here, and you're also able to see any outputted values that you created. So in the case of our example code, we were outputting the IP address of the EC2 instance, and you can see that within the Pulumi console as well. So that is the end of the CDK on AWS or on Pulumi demo. I'm going to go ahead and hand things back over to Josh to provide additional information and wrap things up. But I really hope that you found this demo insightful. And again, if you have any additional questions, please feel free to drop them in the Q&A.
Oh, we have questions, and I don't know if I can answer them all.
Okay, let's take a look then.
Give me 1 second. I just want to drop in one quick note. By the way, so the thing that I'm making note of is someone has asked, someone would be interested in talking to our sales folks. If that applies to you, if you're interested in speaking to our sales folks, please reach out. We'll make getting in touch with our sales folks as easy as humanly possible. All right, let's see some questions here. So AWS CDK creates CloudFormation stacks. Is that true?
It does. It does synthesize down into CloudFormation before getting deployed.
Okay. All right. So if we went into the console in your AWS account, we would see a CloudFormation stack for. Okay. So I think that's actually a change in approach to how to the pre-release, the previous release. Okay. So this makes sense to me. This is kind of how the stuff gets synthesized. So the question was about how do you update a stack which comprises both Pulumi and AWS CDK? It's going to still work the same way. It's still going to be declarative. So if Torian were to go in and change that number of availability zones from 1 to 2, change that number of NAT gateways from 1 to 2, it's going to spin up more NAT gateways in CloudFormation first. Then it's going to.
Sorry, to clarify, the CDK. To my knowledge, the native CDK, like native AWS CDK, does create CloudFormation stacks, but Pulumi AWS CDK adapter creates the resources through API. It's different.
Okay. Sorry. So yeah. So to clarify, it looks like you would not see a CloudFormation stack, but if you want to do interop, by the way, between any existing CloudFormation code. you can absolutely reference a CloudFormation stack in Pulumi. I have that somewhere. I'm going to go find that. I'm going to share my screen. All right. So if you want to see what that looks like, let me just make sure I'm sharing the right screen here. Okay. So I have that somewhere. So I actually wrote a couple days of foundational. This is if I spell it right. Nope. That's not where it is. It's a GitHub. And in here, and by the way, this is a public repo. So if you're interested in like doing your own self-guided training, this stuff should be pretty usable. Again, it's not going to be as polished as it would be in a learning management system. But I do have these slides on Pulumi import, and there's some example in here. Yeah. So for example, if you wanted to, nope, that's not CloudFormation. Sorry. But this is how you use. So somebody actually asked in the chat about how do you look up an existing resource. This is a very short example. It's in TypeScript, but translates. It's also available in Python in these slides. And I'll just drop these very quickly in the chat. So if anybody wants, by the way, so I wrote the majority of this. So if you like it or don't like it, I would love to hear from you. If there's any issues with this, if you start using this training on your own, please, by all means, file an issue on GitHub. I'll do my best to be as responsive as possible. So here's an example of how you can grab an existing resource in a Pulumi IAC program that is not under Pulumi IAC control. So every resource in Pulumi has this get function attached to it. You give it a little name, you give it an ID. The ID differs by resource, and then you can grab it, and you can look at the properties of that thing that you just grabbed. All right, so that's example number one. If you're working with CloudFormation, you can do get stack output, and then use that value. You can grab that value and then use it in a Pulumi resource. So that's how you can interop. If you have existing CloudFormation stuff, you don't want to change it, you can. This is what you can do. In addition, if you have a bunch of CloudFormation stuff, you're like, we want to get rid of CloudFormation, we want to go all Pulumi, you can do what's called import, and there are also notes in this same file that should explain generally how it works. But essentially, you can you give the type of the resource, an ID, and a name, and we will grab it, put it in your state file, and then we will give you the code as an output. And that's an open source feature, so you're going to be able to use that with everything. Let's see what other questions we have. We do have a question about, let's see. All right, so we have a quick question from Dimitri. Could you show the integration between a GitHub repo and a Pulumi deployment? Yes. So I'm trying to think of where I have that. Give me 1 sec to look this up. But one potential example, I'm just going to go digging through a private repo. It's not like there's anything super secret in here. I just want to make sure I get. So we have a. Nope, this is not it. Give me 1 sec here. So we have a repo in Pulumi. I'm sorry this is taking so long. We have a process in Pulumi. This is not the most impressive. Sorry, folks. Give me 1 sec. This is a very, very, very simple example. But within Pulumi, we have this repo. We have a ton of repos in GitHub, right? We manage permissions to that repo with a little custom built tool. Basically, you define the organization structure in YAML. And this is one of the powerful ways that using general purpose languages makes IAC easier. This would be really, really hard to do in other IAC tools. So we keep basically who belongs to what team, and then what teams have what access to what repos. We keep that in a YAML file. And so this is an example of the feedback that you get from within GitHub. So if you're using GitHub for your pull requests, this is an example of where you would see a preview on in the pull request, and then once it's merged to main, it would typically fire an actual update. So essentially, this is not the most interesting diff, but this is essentially the diff that's coming back from Pulumi deployments to tell you that, hey, this is what we will do once we merge this to main. We will add this this GitHub team membership. So that's a simple example. Let's see if there's any other interesting questions. Okay, so we answered that. I think we have most everything answered. Is there anything else that folks want to ask about? If there's anything we haven't touched on, we are happy to touch on that. Oh, we have a question. Here's a great question. What is the most popular language used of Pulumi? So today, as I speak, it is indeed TypeScript, per Torian's answer. But Python is actually coming up really quickly and will likely overtake TypeScript as the most popular language for Pulumi. I'm guessing that I think there's two things driving that change. One, so TypeScript is our original language. So originally Pulumi was single language TypeScript, and then we added support for other languages as the company grew. But I think there's two reasons that Python is becoming more popular. First is the popularity of Python in AI, ML, data science, whatever we're calling that discipline today. There's a lot of folks coming in from there that are now using infrastructure as code, for example, to define, let's say, resources in SageMaker or Bedrock or things like that. And then there's also the influx of folks who are coming maybe from a traditional sysops background, and they tend to, if they do know a programming language, it does typically tend to be Python first, and because it is very, very easy to get started. So that's what I think is driving that change. But any day now, Python will actually overtake TypeScript as our most popular language. So let's see, are there any other questions left? I don't think so. All right, so we are almost done. Again, if you have more questions, or there's something else you want to see, I will be happy to dive into that. But I'm going to move on towards our wrap-up slides. So we would love it if you continue your Pulumi journey. A couple ways you can do that. If you're not a member of our community Slack, please hop over there. I am in there. I'm frequently answering questions. If you have a particular question, please feel free to tag me in it. A lot of folks will also DM me, but you're going to get an answer faster if you ask in one of the public channels and then tag me in it, because then I will see it. But if you ask me in a DM, only I see it. And so the community Slack is really good. We have a lot of engaged community members who are very active there. We also have a bunch of Pulumi employees in there. I'm in there. I presume Torian's also in there as well. And so the first channel to join, other than the ones we joined by default, would be AWS. Go ask your AWS questions in there. Go ask any questions you have about how to get platform engineering adopted at your company. I would love to help you with those questions as well. So that's the first thing you can do. Second, if you do not have a Pulumi Cloud account, please sign up for one. Individual use is free forever. We don't ask you for a credit card or anything like that. And it's the easiest way to learn Pulumi. You really don't need to go through the trouble of setting up an S3 bucket or anything like that. It's much easier to just use Pulumi Cloud if you're learning Pulumi. And if you have learned Pulumi and you're like, hey, I want to show off what this can do to my coworkers, of course, you can reach out to us for a demo. We'd be happy to help you with that. And you can also start what's called a demo Pulumi organization. We will give you full access to everything Pulumi Cloud can do for 2 weeks, and we still won't ask you for a credit card. So if you want to see like what are the more advanced features, you want to try out the new project wizard. You want to try out let's say you want to try out the advanced features around centrally managing policy as code. You can do that. We're still not going to ask you for a credit card. So please, I definitely recommend, again, if you're learning Pulumi, sign up for a Pulumi Cloud account. Individual use, free forever. If you're ready to show your coworkers what it can do, try a trial org. And then finally, we have a series of platform engineering workshops where we're going to kind of go into a lot of the things that we discussed today in a deeper way. And so there is a link for that in the handouts tab where you can sign up. And then we're also going to send you a follow-up email after when the recording is available. And by the way, this is being recorded, so you will be able to watch this again. And so we will send you a link to sign up for that platform engineering series. I'm really excited about this. This is the first time we've at Pulumi have done like a long-running series of topics that build on top of each other. So, no matter where you are in your platform engineering journey, there should be something in there that you're going to find really helpful. So with that, on behalf of myself and Torian, thank you so much for your time. We really appreciate it. And hopefully we'll see you again soon. So long, everybody.